Hello guys, Maris here. This is the video number 7 from this series of videos. Belongs to a full restoration of Pioneer SX1250. Here on the front we have the stabilizer assembly board. So let's say a power supply board, main power supply. Here you'll have already a full restored board. You see how it looks, no any dust, no any spider, nothing. New thermal paste replaced, new resistors, new trimmers, new capacitors. All the transistors they are replaced, I mean the controlling transistors. Only these two remains the original because they are in good shape. Here on the top for the plus section this transistor was replaced and that one which is there. And one it was here also replaced, this one. So this I take the decision to replace all transistors because it was some stress on this board, was too much overheated here. But this is about the board. Now I want to discuss with you about the diagram and how it looks and what's going on with this power supply. Here on the back you see are all the parts which I take out. So you see it's a lot of stress on these capacitors. Some of them they are bulged, some of them they are naked because of the temperature. So I will leave the board here behind and I want to discuss with you what's going on with this block diagram. So you see here it's stated clear power supply. So this section, let's take a pencil for better. So you see we have here the mains which is connected on 220, 120, doesn't matter. Here you'll have this soft start, you have the dropping resistor in series with the primary winding and the thermal fuse which is connected on this resistor. So when you apply the power on the transformer, when the switch is off, the power on off switch is on, in that moment what's going on? So you'll have the voltage which is coming here, it's closing the circuit and is coming back on the socket. For a few moments all the current which is drawn by capacitors and everything what is here, it's drawn from or through this resistor. If this fuse is not okay, that means this full bridge rectifier doesn't have connection on the secondary winding. Yeah, so try to imagine this fuse it's blown, or this one, doesn't matter. In this moment what's happening? You'll have too much current drawn on this resistor, and because on this resistor you have this fuse it will be blown, and in that time what's happening? You'll have an open circuit here. So sometimes it's better to check also this thermal fuse when you'll have problems with power supplies. If everything is going normally, after you'll have the voltage on rectified on this bridge rectifier. So here you'll have AC, after the bridge rectifier you'll have DC. You see here it's a wire which is going to this relay. So this relay belongs to soft start. You remember we cleaned this one on the previous videos. So this relay he is bypassing this resistor here. Okay, so now you'll have full voltage on the primary of this transformer. Okay, so now let's come to our power supply. On this power supply, which is here, these two bridge rectifiers belongs to the power amplifier board, I think on the right channel. Yeah, so these two bridge rectifiers, they are giving the DC voltage to the main filter capacitor which belongs to the right amplifier. Yeah, okay, so after that you can see here one bridge rectifier, it was on the protection board, you remember on the previous video. So you see it's here, yeah, and another pair of bridge rectifier with resistors, not dropping resistors, these are discharging resistors for the main capacitors. It's here. So this one is for the right, on the protection board it's for the left channel. Yeah, so you'll have here. After that, on this board what you have more? This bridge rectifier is on the main power supply. Yeah, you remember the first board which we overhauled for the first time. After this one you will have, you see it's a wire here which is coming for this power supply, and the wire here also which is coming for this power supply. If we are going and we are looking on the diagram which belongs to this power supply, which is on the front of us, we'll have this one. So here is the section which belongs to the power amplifier. So this one is already discussed. On this board, it's exactly I replace exactly like for the protection board these two resistors. These resistors are 3.3K, 3 watts, and I replaced, so these are R15 and R16. I replaced with 3.3 kilo ohms and 5 watts for better dissipation, and I raise a little bit more than original to have more space between the resistor and the board, to have more airflow which is passing there. And if I will have more airflow, that means the temperature on the resistors, it will drop more. Okay, so on the block diagram, I said we have two wires which is coming out from the bridge, full wave bridge rectifier, yeah. And these two, you will see you have here two power supplies, one for positive and one for negative, with references on Zener diodes and also references from the output after stabilizer, yeah. Okay, after that you'll have here a transistor, and from the plus and the minus you have another pairs of transistors which they are doing another jobs. So that means you'll have more voltages on the outputs here. So here you'll see on the diagram where the voltage is going. So control section, equalizer, amplifier, protection circuit, and the power amp. So you'll need different voltages for this. So like I said, this is the block diagram. Now we'll talk only on the diagram which belongs to this board here. So like you see, here are some pins on the bottom. Here you'll have the connection for this section, resistors and bridge rectifier and all these filtering capacitors which belongs to the, let's say for the right power amplification board, yeah. So the voltage from here is going directly on the power transistors, yeah. And now we'll discuss the second section, which is this one, which is the main power supply, let's say. Okay, so now we'll have like that. We'll have pin 6 and pin 15. You will have 85 volts here, minus 87.5 volts here. So this one is coming from that bridge rectifier. And we will have here another voltage which is coming from on pin number 7, and here you will have 23 volts, yeah. Okay, so on pin 7 you will have the voltage according to the block diagram, which is coming here from the other two windings of this prime or of this secondary winding, yeah. So you'll have this here, and you are energizing these transistors here, okay, which are on the bottom. Okay, now let's continue. So let's start like that to see what's going on with this part. So you'll have 85 volts which is coming here on the transistor. We'll do you see, if you are looking, it's like a view in the mirror. So on both sides are similar, yeah. You'll have here some filtering capacitors and smoothing capacitors. You see here you'll have a resistor. That means here it's a voltage divider. You see, you'll have here a voltage, and you see 85 volts. Here you'll have these capacitors for filtering. Also is down, it's same. If you are looking on the resistors are same, 2.7, 2.7, 2.7, 2.7, yeah. So that means it's one divider. Okay, so these smoothing capacitors, after that you'll have these transistors which I replaced. I will show you in a moment exactly the models which I put inside. Here are the Zener diodes for references, yeah. Another diodes connected between the base and emitter of these controlling transistors. You will have the signal on the base of the transistor Q3 and Q7, which is coming from this voltage divider here, and you can adjust according with VR1, VR2. So here you will have a voltage drop because it's a voltage divider. You will take the signal from this segment here. You will take this voltage, you will put on the base of this transistor, and this transistor here will activate the base of Q2. Q2, it's a part of this Darlington setup here, and this voltage and the current, they will activate the base of Q2, and in the same time the Q2 he will open the connection between collector and emitter, and the voltage it's passing here. If you see, you have here 85 volts and here you will have 65. That means you will have a voltage drop across this transistor. So this transistor he will regulate and he will try to maintain the value which is taking from here. So with this VR1 and VR2 you can set the voltage according with the manual. Yeah, in the manual it's stated very clear what is the procedure for this. I will show you in a moment, but this we will do when we'll put the boards on the amplifier. So you see here stabilizer, yeah, adjust VR1 for 65 between terminals number 17 and 12, adjust VR2 for 65, I'm reading here, 65 between terminals number 12, ground, and number 16, yeah. So you will adjust from these two, yeah. So here we have another capacitor. This capacitor here is smoothing the voltage on the base of this transistor. This one also here it's smoothing the voltage on this base of transistor. We'll have here another two capacitors which are smoothing the voltage on base of this transistor, and also they are smoothing the voltage which is created by this zener, you see, because here it's a zener and a resistor. So on the output of this transistor you'll have this resistor capacitor, so that means here you'll have a voltage, with the voltage which is going on the base of this transistor. So it's a reference. If you are looking here, you'll see. So let's look on the voltages. So I said here it's 65 volts. You see here on the base of this transistor is 65. And here it's minus 65. So that means you'll have on the base of this transistor minus 65. And now we'll take this point. Yeah. So because you'll have a zener here, you'll have a voltage 65 here. That means here you'll have 25.5 volts. Yeah. This 25.5 volts is going on the base of this transistor. You'll have here another dropping resistor, so that means from 65 volts you'll have here some voltage drop. Also this resistor I replaced because it was with cold joints and for sure was some stress on this resistor. So you'll have another voltage drop here, another voltage drop on this transistor, and on the output here you'll have 25 volts. So you see the base of this transistor is 25 and here you'll have 25. Yeah, if you are looking here you can see 36.9 volts. So that means the voltage which is dropped on this resistor is 65 minus 36.9, and you'll have the voltage which is dropped here. And another voltage drop, like I said, it's between 36.9 minus 25, and you'll have a voltage drop here. You can connect directly the transistor here without any problem. So if you'll bypass this resistor and you are putting the collector here, it will work without any problem. But it will be too much heat and you will stress too much this transistor, because you will have a higher voltage drop on him, multiply with the current which is passing this output, you will have too much power dissipation here. So it's highly chances to destroy the transistor. It's similar here, minus 25 volts, voltage drop here from minus 65, 47 volts, plus voltage drop across this transistor, you will have 25 on the output. Here is the filtering and smoothing capacitor C10 and C9 for this 25 volts, and here is the filtering capacitors for the 65 and the minus 65 volts. So more or less this is the explanation of this power source. For this power source, it's not complicated. It's a, let's say it's a mini power supply, because the schematic is very simple. And like I said again, so it's coming, the voltage is coming from the power from the transformer, from a step down transformer. The voltage is, of course, it's alternating current. After that it's rectified by a full wave rectifier by 4 diodes, and after that it's smoothing down by some capacitors. After that the voltage is applied on this on these collectors of the transistor Q2, Q1 and Q6 and Q5. Yeah, the voltage of the base of the transistor Q3, you see this one, the voltage which is on the base of Q2 and Q6 is governed by the transistors Q3 and Q7. Yeah, and these transistors, they are governed by the voltage from this voltage drop resistors, yeah, from these two adjusting points. Okay, so the voltage, like I said, is going on this space, and you're opening and closing these transistors according with this reference on the output. Here, like you see, it's are 3 resistors. The trimmers will replace these trimmers, which they've been on position here. They were open, so they are already tarnished because of the time, and also it's some dust inside. So I prefer to replace them with some new sealed potentiometers. So this is with the first section here. So like you saw already, 2 voltages that are coming inside, 85 volts with respective for the ground and minus 87.5 with respective of the ground. From these two, you will have 4 outlets, plus 65 and minus 65, which is done by these groups, first group, second group. And from third group and fourth group, you will have 25 volts and minus 25 volts. And this section, it's done. After that, we'll come on the second section. Like I said, we have pin 7 where you have 23 volts is coming here. Also, you will have again some voltage, some dropping resistor. Here it's first one, R17, 3.9 ohms, half watt. This one it looks okay, so I was not replacing. It's still on position, but this one was not in good shape, and it was necessary to replace. 100 ohms, 2 watts. I put 100 ohms, 3 watts. Yeah, so let's start with this one, which is going on the top. If you are looking, the circuit is similar. It's really similar with this one for positive side here. So it's again a Darlington pair made by 2 transistors here. This transistor I told you remains original. This I was replacing, and this one I replaced also. I will show you on the parts list exactly all the components what I replaced. Okay, so let's look again. So you have here a voltage drop. Yeah, so you have 23 volts voltage drop across this resistor, and here on the inlet of these 2 collectors you have 20 volts. So that means here I have 20 volts. On the output of this emitter of the transistor Q9, I have 13.5 volts. So 3 volts I have dropped on this resistor, and the difference between this one and the voltage drop on the transistor, it's dropped here between this collector and emitter. Okay, so let's go opposite. We have the base here of this Darlington pair. The base is going on the collector of this controlling transistor, which is Q11. Yeah, this one he is taking the voltage from this diode, Zener diode here, like a reference. So you see it's 6.1, the reference which is coming here. After that, here I have 6.7 volts, and the reference is taken here on this voltage divider, 1K, and 13.5 volts, yeah? So you see, because it's 1K, that means it's a half, yeah? So 13.5, the half is 6.7, it's correct, yeah? So I have 6.7 here, 14.9 here, because you will have also a reference which is taken from here, from 25 volts, yeah? Another reference, and in this way it's you see here 14.9, yeah. Okay, because you have this voltage, you have this resistor here which is creating again a voltage drop, so you'll have here 14.9, and in this way you will have the output of 13.5. This capacitor here, it's smoothing capacitor for this voltage. This capacitor here is smoothing capacitor for the base of this transistor, and this one it's smoothing capacitor and filtering capacitor for this 13.5 volts. Okay, so this is the output of this section here, and here on the bottom we have another section, and the last one again. So 23 volts voltage drop resistor. This one I told you I replaced, and here you will have 13 volts. So that means you will have 10 volts drop across this resistor, yeah? Here you'll have 13, here is the smoothing and filtering capacitor, because you see it's going on the ground, here is the ground, yeah? You'll have 13 volts here, you'll have this transistor which is here, yeah, with this capacitor, filtering capacitor, which is connected to the ground, and here is the output, 5.4 volts. And you're controlling this 5.4 volts with this transistor here, which is Q13. Here you will have a smoothing capacitor which is going on the base. Here you will have a resistor, and here you will have another resistor which is taking the voltage from here, 13.5. But if you are looking here, it's a voltage divider because you have 16K and 1.5K. If you will make the calculation from 13.5 volts with these two voltage dividers, that means you will have 6.6 volts according with what is written here. And you will have, of course, the voltage which is dropped on the junction of these transistors. On the outlet you have 5.4 volts. So more or less this is the explanation of this power supply. Like I said, it's an easy power supply, but you have to focus on them. What I found on this board, because this is the only board which I saw some action when I opened, I found like that. This transistor it was not original. This one was not original. This was not original, and this diode here was not original. So what happens? Sometime before this section was blown. So if this section was blown, that means also was missing 65 volts, was missing also 25 volts, and that means it was also missing this voltage here, this 13.5. So a lot of voltages here they've been out of order. So also what I found on these resistors, the voltage dropping resistors, I found cold joints. So that means a lot of current was passing them, and of course some heating was created more than normal. But all of us, you know, the Pioneer, it's using hot power supply, and I'm trying all the time to reduce this heat by installing new parts. Usually smaller capacitors in dimension to have a better flow on the circuit here. I'm replacing transistors with bigger packages. It's not a 92 package like they've been original. Usually I'm putting 126 transistors, and for sure it's better for the performance of this power source. Okay, now let's talk a little bit about the position on the board. So here it's another diagram which is explaining us exactly where are the components on the board, but pay attention for this type of printings, because you see they are opposite than the boards. So all the time you have to read the board upside down. If you are putting the board upside down, that means you'll have the proper reading now. So all the time when you are reading the diagram on this side, so that means you are here. So you are going in the mirror, yeah? Because this is the way how they are making, and it's normal. So this view of the circuit, it's from the back side of the board, because you will see the tracings, yeah. So it's normal to be like that. And here are all the parts which I replaced. We have the markings here, and they are stated very well. So I'll put this one on the front of the camera to be much easier for you to see the parts. So I hope it's clear. Okay. So now this one we will put on the side, and we will look. I want to take out the board from the metal support, because I want to show you how they looks the soldering tabs. I made a video and I'm doing this restoration. But my camera, he said he cannot access the card anymore, and the video was lost. And this is the reason why this board it's already done now. Yeah. So here is the board on the soldering side, yeah, on the connection side. You see everything, it looks perfect. I reflow all the joints, because some of them they were not in good shape, yeah. Here are the pins, all the pins are cleaned. You know how to clean. You have to use a pencil eraser. You put the eraser like that, you'll make a hole on the eraser and you'll clean all the pins. So let's fix now the board back, because I don't want to touch the back side. And now we'll discuss about the parts which I take out and all the job which I did now here. Okay, so like example, all the capacitors now are rated for 105 degrees, yeah, because you know, the board is running a little bit hotter, and all the capacitors, they are rated for 105 degrees. So I want to show you these capacitors which they've been inside here and I took out. You see, like example, these are 220 microfarads 80 volts which they've been here. I choose to put here 320 microfarads and 100 volts. About the temperature, you see, it's written here 85 degrees. So I replaced all the capacitors, like I said, with 105 degrees, like you see also here, 105 degrees temperature. This capacitor, axial capacitor, it was here, and this one is the old one. Also, you see, this one was 65 degrees. So this it was on that times. Okay, and the rest the capacitors, if you are looking on them, some of them they were bulged. You see, this one on the bottom, it's bulged. Also the protection, the plastic protection was removed. You will see some dots on the capacitors. I put that dot where it was the minus for better reading. You see, this one, the sleeve was going down. You see. And it's normal, it's nothing strange, but this is the reason why I say all the time, don't play with them, because you can manage to have a big damage inside according with these old parts. Okay, so like I said, we'll take in the front of us the diagram and we'll discuss about transistors. Yeah, like I said, on position remains only the transistor Q9 and Q12. Q9 and Q12 are these two transistors which they are taking care about the 5.4 volts, this one, and the second one is this one, 13.4 volts, the driver transistors. Yeah, but the transistors which are driving these power transistors, I replaced them. Okay, so here you'll have all the replacements which I done. So like example, transistor Q1, it's 2SD313. This one, like I said, it was not original. So because I don't have original on stock, and even if I will have original on stock, it's rated for 3 amps and 30 watts. So I take the decision to replace this one and Q5. So Q1 and Q5 are here. Yeah. So they are dealing with this 65 and minus 65 volts. And of course, after them it's coming that voltage is minus 25 and 25 volts. So it's a lot of, it's passing some high amount of current through them. I take the decision to replace both of them with MGA 15032 and MGA 15033. And these transistors are rated for 8 amps and 50 volts. So it's better than original. The case of these transistors, it's the T220, yeah, so you'll see here. So you don't have to take care too much about the terminals, because the terminals are exactly like are all the time the same. So you'll have base, collector and emitter. So all the time try to keep in mind the collector is connected to this tab. So you have to make because you see both of them, they are sharing same heatsink. You have to isolate the collectors, because here you have plus, here you have minus, and you will put plus and minus together. You know better than me what's happening. Okay, so for these packages, for this package T220 is not necessary to take care about too much the terminals. Yeah. Okay, so these two transistors, like I said, I replaced. So this Q1 and Q2. Now this Q1 and Q2 belongs to this Darlington segment. Yeah, Q1 and Q2, they are driven by Q2 and Q6. For Q2 and Q6, I used, normally it was 2SC869, sorry, 2SC869, and for Q6 it was 2SA628. So let's put here a dot to know we discuss about them. And these transistors I replace with KSC2383 and KSA1013, which are bigger package, and they are doing a good job there. Okay, so this for these two. Also pay attention for the terminals. Yeah, this Q2 is driven by this Q3 and Q6 is driven by Q7. So Q3 and Q7 I replace with Q3. Normally it was on position 2SC1318 and I put KSC1845, and for Q7, which is here, it was on position 2SA720 and I put on position KSA1992. So like you see, these transistors which I use are complementary one to other. So that means I will have a better performance of this power supply. So now I know the transistors are complementary and they are doing a good job there. Yeah. For transistors Q4 and Q8, yeah, Q4 and Q8, keep in mind, Q4 it's 2SC1384. I use KAC2690, which is a bigger package than original, and for Q8 I use KSA1220. So this is the complementary of this one. So Q4 and Q8. These two are here. So you see are bigger package. Yeah. So for sure now I will have a better dissipation now. You see these two. And before there it was this one and this one. Yeah, I forget also this one here was damaged also on the plus, because like I said, all this part here was with problems. Zener, this transistor, and this one. I forget about this one to tell. Yeah, so like you see, it was the service. It was done somewhere in Europe, because this is a European transistor. So this was the original transistor which was here for the minus. Yeah, I replaced both of them with that transistor which I told you. So now all the transistors which belongs to this part here, they are replaced. Yeah, and for better performance I told you why I did like that. Other transistors is this Q5, it's marked. Q9 and Q12, we said already, they've been original, only I replace the thermal pad and I take the measurements and clean the terminals, and they are on position. Now we have, let's start with Q10 and Q11. So let's make it Q11. Q11 is to SA945 and I replace with KAC1845, and Q10 it was on position 2SC945 and I replace with KAC2383. So already you have you'll have already, so I said Q10 and Q11, yeah, KAC1845 and KAC2383. Yeah, so this one it's 90 package, and this one it's a little bit bigger, yeah, comparing with the original. So these two transistors, they are belongs of this circuit here, yeah, for driving also in the Darlington pair to driving the K9. Yeah, so these two transistors are, this one it's one which is driving this one, and here it's another one which is driving, this transistor is driving this one, and after that the big transistor. Yeah, okay, so remains, so let's mark this Q10 and Q11, and remains Q13. Q13 is KAC2383, which is here and is driving this transistor. Yeah, okay, Q13, before it was 2AC945 and now it's KAC2383. If you are looking here, also Q11 it was like Q13. Yeah, for Q11 I put smaller transistor, because this smaller transistor he is playing this to KAC83 2383, and from this one the signal is going on this one. So you see they are in from small to big, let's say. Yeah, here I put directly KAC2383 because this transistor is driving directly the power transistor. Yeah, so this is the reason. Here you'll have T transistor, here you'll have only 2, and I prefer to put here a bigger one. Yeah, too much talking, I know. But this it is, what we can do. Okay, after that I told you about some Zener diodes. This board, he is using 3 Zener diodes. Yeah, 2 of them are 24 volts. One of them, it was replaced with this one was replaced with 2 Zener diodes 12 volts in series to create this 24. I don't like something like that, I replace. And also here down you have this reference diode, which is 6.1. Yeah, and you can see here I replace with 24 volts, D1, D3, and D5, and 1 watt rating. I prefer to go with like that. So this is this Zener, which was made by 2 Zeners in series. The other 2 Zeners are these 2. So I replace all of them. Usually I prefer when I replace a part to replace all of them to be sure everything it's same. Yeah. So all these transistors, they've been replaced somewhere in Europe. So this one BD, and here RBC and BF. Yeah. So they don't belong to Japan. Yeah. So they are in Europe. So or are for Europe market. Yeah, it's constructed in Europe. So here are the rest of transistors. You will see you have already tarnish on the terminals, and I replace with bigger transistors for better performance. Also, I told you about these two resistors, these 2 potentiometers here, which are from Burns. I replace also them, and instead of them I put them in place of this original, which they are already tarnished, and it's a lot of dust here inside. Okay, so now let's look for resistors. About the resistors, I told you I replace some of them. We can start to be much easier. We'll start with R15 and R16. There are 2 resistors which are here, and here on the diagram they are rated for 3.3K and 3 watts. I use 3.3K and 55 watts, both of them, for better dissipation, like I said already. You'll have here the dropping resistors for the minus 25 and minus 65 volts. One is 1.5K and the other one is 680. So our R13 and R14. R13 is this one here, which is rated for 680 and 2 watts, and I use 680 and 3 watts. And this is the plus 25, and for minus 25 it's stated 1.5K 2 watts, and I use 1.5K 3 watts. Here it's 5, but it's 3. Not 5. 5 it was too big for this purpose, yeah? So it's 3 watts here. After that we have this R18, which is voltage dropping resistor for 5.4 volts, yeah? And this one was stated for 100 watts and 100 watts, 100 ohms and 2 watts, and I replace this one with 100 ohm 3 watts, which is this one here. About the resistor, the original resistors are here. Okay, this I replaced because also I told you I lift it a little bit more up. I bent the legs like that to stay better on the board, yeah. For all of them, if you are looking. For this one I squeeze a little bit the terminals, but for other 2 here also I bend the terminals, this one and this one. So for the resistor I will keep again on the front the list to be easy for you to read. Okay, about the trimmers I said already. The trimmers which are on position, they are 4.7K, almost 1 turn how to say, adjusting distance, let's say. Okay, and for this I use 5K3386H. These trimmers are from Burns and are completely sealed. You don't have to be worried about some moisture or dust which is going inside. I adjust these trimmers. So usually how I'm adjusting this trimmer, I will take the trimmer out. I will connect a lead of the multimeter on the middle on the wiper and another one on one terminal. Doesn't matter which is other terminal, but you have to keep in mind to make same connection for the trimmer which you will put inside. So if I will put a hook here and another one here, on the new potentiometer which I will put inside, I have to put the hook here and the hook here. After you will put the multimeter on this trimmer, you will have everything. Like example, this one was 4.2 kilo ohms. So write down 4.2 kilo ohms. Disconnect this trimmer, put new one, and we will adjust the new trimmer for 4.2 kilo ohms. But keep in mind, not all the trimmers are similar. So the resistance on them, it's all the time can be different. You have to keep in mind when you'll connect the mains of this receiver or power supply, you have to keep in mind you have to use the variac and the dim bulb tester, yeah, because you never know what can go wrong. And after that, you will make the adjustments according to the diagram and the test points. Okay, so now let's talk about capacitors. For capacitors, you see here it's all the list with capacitors. Here are the parts which they've been inside, the values, and here are the parts which I was using. So let's start like that. C1 and C2, 220 microfarads, 80 volts, and 85 degrees. I put 330 microfarads and 100 volts. These are Nichicon. Usually I'm using low ECR capacitors, and the series which I'm using it's UHE, UPV, PY, depends of the stocks. Yeah. So for this I use 330 microfarads and 100 volts, which are here. After that, C5 and C6, 47 microfarads and 35 volts. I use 47 microfarads, 100 volts, 105 degrees. C7 and C8, 22 microfarads and 50 volts. I use 22 microfarads and 100 volts. C9, C10, 100 volts, 35. I put 100 microfarads and 35 volts. I put 100 micro and 50 volts. C11, C12, 47 micro and 80 volts. I put 47 and 100 volts. This C13 is this one, which is axial, 1000 micro and 25 volts, which is here. I put, you see, 1000 microfarads and 35 volts axial. All the parts, I forget to tell you, I bought from Mauser. It's the most handy platform for me for buying the parts, and I have them in the front next to the door very fast, so it's very good. C15, 47 micro, 10 volts, 47, 50 volts, and the rest C16, 22 micro farads and 10 volts, 22 micro and 100 volts is this one, which is here, this one. And what remains? C17, 220 microfarads and 16 volts. I put 220 and 50 volts, which is this one here. And the last two, 47 microfarads and 10 volts, I replace with 47 microfarads and 25 volts. Yeah, these are these two smaller here. And I show to you the capacitors, all are here. They looks how they looks. Yeah. So now I'm on the center of camera. So all these are the parts which I replaced. I like to put them on the bag. And on the bag I'm writing the device, Pioneer S612, protection board, and the name, yeah, and the numbers of parts which I take out. So this is the power supply board. They are calling stabilizer assembly AVR 106. Yeah, so I will put again the list on the front of you. Maybe some of you want to follow this. Yeah, I found this is the better way to do. If you like this kind of work, what I'm doing here, please subscribe, thumb up, share with others. Please don't forget to leave the comments. They are helping me. It's not easy for me here to talk in the front of camera, but I'm doing this because I know you are there, and I'm trying all my best to make a good content for you. Yeah. I told you this is another kind of video because I was making a video when I did this restoration, but because the camera encountered some error on transferring the information on the card. He was let's say he was losing the content, let's say, of that video, and he was erasing. On the end of this video, I will attach a small video which I was able to make when, if I remember, when I put these two transistors back. So I will attach on this end. Yeah, about the transistors, you know, when you are taking out a transistor, you have to check the position on the board. You have to check also the markings on the board to be fitted with the terminals. Not all the time it's like that. Also for capacitors is the same. Check where is the minus, where is the plus, and put the capacitor in the same way, even if on the board it's stated different. This is the reason why I'm using block diagram, the circuit diagram, and this diagram also. I don't trust this so much. I prefer to trust this one because here I can see how the parts they are in position, and because we understand, all of us, the voltages and everything that is here, we will understand much better the position. About the transistors, you can use different instruments. Like example, I like this one, which is a multi-tester. It's made by somebody, and the processor, it's the IC. He is using a program, if I could remember, it's made by one Ukrainian guy. Maybe I'm wrong, I don't know. You can use also Atlas DCA 55, which is really doing a good job. And you can use also this cheap Chinese unit, yeah, which is doing also a good job. But you see, for this one I don't have a box. I have to create a box, but because of the time, you know. So I'm using this one. How I'm using, what I'm looking for on the transistors is very simple. So you'll take the transistor, after you'll take out from the board, you'll put with specification to you with these markings. Usually the markings are on this tab. You'll press test, and this one it will tell you exactly 1, 2, 3 CBE, yeah, collector base emitter. Here is the power amplification factor, HVE, it's 174. UBE, the voltage between base and emitter, 661 millivolts, so 0.6 volts. And that's all about transistors, yeah. And this one I'm using because you see he's using these pins here and is doing a better job. For this Chinese one I made also same, yeah. And you'll put here, I solder this. So let's connect the battery, because I want to show you also how it looks. Also the Chinese one, it's nice, but I told you I prefer this one because it's already in the box, and he's doing a good job. Okay, so you see battery connecting, tested. So you have to open this one, and you have here 1, 2, 3, yeah. So you have to put the transistor here, close, and press. You see HV171, voltage between base and emitter 661, and one collector base emitter. So one collector base emitter. So you see it's doing same job, yeah. It's up to you which one you want to use. Or I told you I put this one here. You can fix like that, and again press, and we'll see if it's making a reading. CBE 1, 2, 3, yeah. So if you see, it's very easy. So you can use what you want. Now let's test also the Atlas. DCA to see what's going on there. Okay. So try to keep in mind exactly like for television. Red, green, blue. Red it's on. RGB, yeah, red, green, and the blue. Let's see what it's saying this one. Analyzing. NPN transistor, okay. Red, green, blue, you see, collector base emitter. HV, the beta amplification 131. Test current of collector 2.5 milliamps. Base emitter 0.739. Test current base current 4.22. Leakage current is no leakage current, so that means it's good. And this is about Atlas DCA. So use which one you want. Sometimes I'm using all three, depends of the. Usually I'm using all three when I'm making the HV matching for differential transistors. I prefer to do all the tests for better result. I will show you also on that moment how we'll do this. So I can say this board is ready. Thank you for your watching time. Now it's end of video number 7. On the video number 8 we'll talk about power boards, power amplification boards, and we'll try to finish that 2 boards, to clean, to install parts, to discuss on the diagram what's going on. And I told you, if you like this kind of content, thumb up, leave comments, share with others. You will help this channel on this way. And if you have feedbacks, if you have suggestions, don't hesitate to put down, because I will try to follow them, I will try to answer to you, and I will try to, like that, to make a better content for you. Thank you very much. Stay safe, stay tuned, new videos they'll be released for sure, and see you on next video. Bye bye.